right, today we are going to talk about annuities. Okay, so first we want to talk about what an annuity is. An annuity is a sequence of payments at regular intervals of time. And we will always, for this class, use the end of a period for payments. So if you take a class in finance, they're probably going to not always take the point of view that the payments will be at the end of the period. Sometimes they'll be at the beginning of the period. And so there's different formulas and all that stuff. And so things get a little more confusing. But we're gonna not deal with that situation. We're always going to have the payment at the end. So an example of an annuity that you might have heard about in the real world is, say, a Powerball winner. That's a type of lotto game of, let's say, $100 million. Usually, we'll get paid in something like this. We'll receive payments of, say, $5 million per year for 20 years. Okay, so this is called a 20-year annuity with payments of $5 million a year. Now, when you see this person on television with the gigantic check and the balloons and stuff like that, the check says $100 million, right? But that's complicated. That $100 million is a complicated amount. In fact, in many ways, it is a fake amount. It is not a real amount. Oftentimes, you'll see when sports contracts are being discussed and a player signs a 10-year, $200 million agreement. That is also a fake value. It is not the actual value that, say, an accountant would put to that amount. Why is that? Well, because when payments are put off to the future, they're worth a different amount than they would be made today. Okay. Why is this evidently the case? Well, okay, I can promise to give you $1 million tomorrow or $1 million 100 years from now. Those are not the same thing. Right? They're both $1 million, but they're in no way the same thing. Right? One of them has no utility to you at all because you will likely be dead at the time that you would receive that $1 million. Right? The other one has some real utility to you right now. So valuing annuities is somewhat complicated. Okay? So because money has a time value, the value of an annuity is complicated. So we're going to have to come up with some definitions and formulas to try to figure out what is going on. Okay, so here we begin to kind of systematically try to figure out how to value an annuity. That's our job right now. So we are going to name the value of each payment. This is called rent. It has only something to do with the rent you would pay for an apartment. This is just the word that's used in accounting for this. The value of each payment is called the rent. So the rent for the previous Powerball winner is $5 million per year. The future value of an annuity is equal to the total amount of rents received and the interest gained from them. Okay, so you might say, oh, the future value of that annuity in 20 years, that lotto person is going to have $100 million because they got their $25 million payments. But that's not a good way to think about it, because 20 years is a long time, and interest is a real force of nature, which, you know, you guys probably don't buy groceries, but those of us that do buy groceries have noticed this a little bit lately. Okay, that prices change over time. And so the future value is what you would get if you took each of those $5 million and then put it in a savings account. So that first $5 million that you got at the end of year one would have 19 years to grow. The second $1 million that you get at the end of year two would have 18 years to grow, and so on and so forth. Then you would have a certain amount at the end if you didn't spend any of it. And that's called the future value of an annuity. Okay? The present value, an annuity, is equal to the current amount one would need to invest today to equal the future value. Which is called the present value of an annuity. Okay. So let's take a look at the situation above. We want to find the present value of the Powerball winnings and perhaps the future value of the Powerball winnings, right? So the present value and the future value. So if one is given, so the only way we can do this problem is if there's an interest rate inherent, right? Because we're talking about the time value of money. The only way to do that is to calculate with an interest rate. So let's fix an interest rate. Let's fix a rate of, let's say, 4% interest per year. Okay. Now, if I do that, if I want to find the future value, right, I need to take the following calculation. I need to take $5 million, and that first payment, I need to multiply that by 1.04 to the 19th power, because I received that payment at the end of the period. We're always assuming we're receiving our payments at the end. And then if I receive that payment at the end of year one, it has 19 years to grow until I receive the final payment. So that first $5 million is actually equal to, in future value, this is really $10,534,245.88. But that's money in the future, and we can't think of that as money now. So $5 million at the end of year one is actually worth $10.5 million at the end of year 20. And that's not the only payment, right? We have 20 payments. So to that, we'd have to add 5 million times 1.04 to the 18th power. That's year two. So there's 18 more years to compound. And we have to keep doing this with each of the $5 million payments until the penultimate payment which has 1 year to accrue interest, and then the final payment, which is $5 million. And it's worth exactly that, because you get that $5 million at the end of year 20, and that's what it's worth, because you're valuing it at exactly what it's worth. So we'd have to add up all these things together, right? And there's nice calculators that can do this, and we're going to learn, if you have a TI calculator, how you can compute these things with the TI. We're also going to learn formulas that you can plug in, and you don't need to use a fancy financial calculator to do it as well. But when you add all these things up, you get, let's see, I've got 148,890,392.9, which seems wrong, because it can't be, it's got to be more than 20 million. No, it's got to be more than 100 million. Okay, yeah, this is probably right then. Okay. So that $100 million nominal payment is not actually, if you save it all, you're going to have almost 150 million at the end of the 20-year period. Which obviously no one is going to do, right? Unless you already have millions of dollars and you can just let those winnings accumulate. Right? No one's going to do that. But this is useful for finding the present value, because the present value says the current amount you would need to invest today to equal the future value. So the present value is kind of easy to find if we have the future value. The present value is equal to the future value, if the present value, if we let it accumulate for 20 years, it's equal to the future value. So that is the future value. And do we see why this equation would tell us how much we would need to invest today to get that value in the future, right? Because we invest at 4% for 20 years, that's 1.04 to the 20th power. Okay, so let's see how this works. So this would be 1.04 to the 20th power. That's about 2.19. And then we divide that into 148,890,392.90, and we get $67,951,631.73. So this is really how much money is won at the time when the person wins the lotto. When the Powerball is drawn and it matches, and that person is holding the ticket, that ticket at that moment is worth $67,951,631.73. Because that ticket is equal to 20 years of payments of $5 million. And if you let that accumulate at the current interest rate, you get $148 million. And how much do I need to invest today to have $148 million 20 years in the future? That is 67 million, or almost 68 million. Okay, so these are how these things are counted, right? This seems like a strange way to count things, right? Because this is such a huge amount of money that why would you even think in this manner, right? But this is, of course, how banks think about this. Banks have huge amounts of money, and they must decide what to do with them. So they have to have a smart way of thinking about how much this is worth, right? If you or I were given this ticket, I don't know how wealthy any of you are, but if you or I were given this ticket, right, we wouldn't really care whether it was $5 million payments a year or $4 million payments a year or $6 million payments a year, right? It's almost equal to us. But that's not the point of view we take in finance, and that's not the point of view you can take in business. You have to be a little bit more shrewd than that. And that's what this is about, how to be shrewd in this manner. Okay, so we need to give here a formula here for future value and present value. So here's the formulas that we need. Okay, so this is, of course, something that you can write down on a sheet of paper and bring with you to the test on this section. So the final value, the future value, is 1 plus the interest rate raised to the number of payments minus 1 divided by the interest rate times the rent. And I'll show how we can do this from the example that I just did. We'll put those numbers in and see that it comes out to the number that my calculator magically gave me. Now, the present value of an annuity is a similar formula, but a little bit different. Here, we have 1 minus 1 plus I to the negative n power divided by I times the rent, R. Okay, and let's carefully highlight what each of these things are, right? This n is the number of payments. The I is interest rate in decimal form, right? So 1% is 0.01 in this case. And R is the payment, or the rent. Okay, so those are the two formulas that we can use to figure out the future value and the present value of an annuity. Let's do that with this current annuity we're talking about, this Powerball situation. Okay, so to find the future value, I need to take 1 plus 0.04, because we decided there's a 4% interest rate. I need to take that to the 20th power because there's 20 payments. I'm going to subtract 1 from that. I'm going to divide that by 0.04 and multiply it by the payment of $5 million. Okay, so let's do that. I take 1.04 on my calculator, I raise it to the 20th power, I subtract 1, I divide by 0.04, and I multiply by 5 million. And I get 148, 890, 392, which is, see, the same number we got up there before. Okay. So that's the future value. The present value, I'd have 1 minus 1 plus 0.04 to the negative 20th power divided by 0.04 times that same 5 million. When I do that, I get 67,951,631.72. So, as I said, these formulas will give you exactly what I said they will give you. There's also fancy financial calculators like this here that if you're going to be a finance major or something like that, you should just get this anyway. Okay, that I can teach you how to use that. Or there's also ways that your TI calculator could do this, which is detailed in the textbook. I believe on page, let me find it here. Page 450 of the textbook has some of this information for a TI calculator, if you happen to have that. Okay. Any questions about the calculation I just did? Is this okay? Let me see what's happening. Okay, so let's maybe do one more or two more problems to try to figure this out, and then we will assign the homework. Okay, so here's a question you might at some point ask. How much money do you need to deposit quarterly at 6 6% interest compounded quarterly in order to have $3,000 at the end of two years. So this question is saying, okay, for some reason I know I'm going to have a $3,000 expense at the end of 2 years. I've got some bill coming due, and I want to prepare for that. I want to put a fixed amount away once every quarter or 4 times a year so that I will have that amount. Now, naively, you could say, okay, that's 8 quarters. I could take 3,000 divided by 8 and be done with it, right? But then you're going to have more than you need because that money is making interest when you're putting it away. So it does make sense. Okay, let's do this calculation. So let's identify what we have here. The $3,000 is a future value. The number of periods is not 2 years, it's 8 quarters. And the interest rate is not 6%, it's 0.06 divided by 4. Right? Because we have 4 quarters. So this is 0.0015. Sorry, that's too many zeros. 0.15. Okay, so the future value formula right here says 1 plus I to the n power minus 1 over I. 1 plus I to the n power minus 1 over I times the rent. The rent is the payment. That's what we have to invest. So we're solving for this variable now. The rest of them we have. So we have a future value of $3,000. I have 1.015 raised to the 8th power minus 1 divided by 0.015 times R. Now I use a calculator to figure out what these things are. We raise something to the 8th power, we subtract 1, we divide it by 0.015, and we get 8.43284 times R. Think about that 8.43 for a minute, okay? The 8 we can think of as the 8 payments of $3,000. Or the 8 payments of a mystery number we haven't figured out yet, right? Considerably under $3,000. That 0.43 is the interest that we earn. Okay, we're going to make 43% of a single payment on interest over that 2-year period. Okay, so we take this 3,000 and we divide it by 8.43284. And R is equal to 355.75. So we would need to make payments of $355.75 quarterly in order to make this. If we just naively said, okay, 3,000 divided by 8 payments, it would be $375. So we're putting away $20 less a month. That's what the interest is getting us, to be able to put away $20 less a month. All right, so I'm going to assign the homework assignment now, and you can start working on it and ask me questions. Also, if you have a calculator and you want to see whether it can do these sorts of exercises, I can help you figure that out during this time as well. So the homework, this is section 10.2, is 6, 8, 10, 12, 22, 24, and 28.